Hey everyone, and welcome to today's lesson in which I'll be taking you through some questions on simplifying algebraic expressions. So, a bit of a background to begin with. An algebraic expression is made up of terms that are separated by an addition or a subtraction sign. So, here we have an example. We have x plus 5y squared minus 2x plus 3y squared plus 7. And all of these terms that you see are separated by either a plus or a minus sign. Let's go through the different parts of this expression. Any unknown number can be represented by letters such as x and y and so on. And these letters are called variables. If we have a number by itself with no variables attached, such as 7 in this case, then that particular number is called a constant. If we have a number that is multiplied with a variable, such as 5, 2, and 3 in this case, then we call that number the coefficient. Please keep in mind that the variable x here also has a coefficient of 1, but there is no need to specifically write it, so we just leave it as it is. Now we can go ahead and simplify this algebraic expression by collecting like terms. Like terms are those that have the same variable and power. In this particular case, our like terms are x and 2x, and then 5y squared and 3y squared. So when this expression is simplified, our final answer is going to be 8y squared minus x plus 7. Let's now go through some questions in which we need to expand the brackets before we can collect any like terms. Question number 1. So in this particular case, as you can see, the expressions are within the brackets. So before we can do any further simplification, we need to expand this bracket first. And we can do that by multiplying the terms with each other individually. So let's go ahead and do that. We're going to multiply 5 with what's here inside the bracket plus x times what's inside the bracket here. So when we do that, we're going to get 45 plus 35x plus 5x squared plus 9x plus 7x squared plus x to the power 3. Now we need to combine the like terms in order to further simplify this. So when we combine the like terms, we would get 45 plus 44x plus 12x squared plus x cubed. Let's take a look at question number 2. So we can actually rewrite this in this particular format to make it a bit simpler. So what we can do is bring the 2m and the minus 7 outside of the bracket and then multiply it with the second expression over here. This will give us 2m bracket m squared plus 5m minus 9 bracket closed minus 7 bracket m squared plus 5m minus 9. And when we expand this bracket, we will get 2m cubed plus 10m squared minus 18m minus 7m squared minus 35m plus 63. Now all we need to do is collect all the like terms. And when we do that, we will get 2m cubed plus 3m squared minus 53m plus 63. To further understand how we can simplify a variety of algebraic expressions, I'd like to go through some examples of special expansions with you. So we have certain rules for special expansions, and they can be quite helpful when it comes to quickly simplifying expressions. And I've listed these out on the screen here. Let me show you how we can use these rules by doing some examples together. Example number 1. We have 5x plus 1 and all of this to the power 2. So this is an example of the first special expansion, which is the sum of a square. And we can rewrite this as 5x plus 1 times 5x plus 1. When we expand this, we will get 25x squared plus 5x plus 5x plus 1. and we can collect the like terms, which will give us 25x squared plus 10x plus 1. Let's see if we get the same answer if we use the square of a sum rule. So in this case, a represents 5x and b represents plus 1. So let's substitute these values. A squared will give us 25x squared. 2 times a times b will give us 10x, and b squared will give us 1. So all of this combined will give us 25x squared plus 10x plus 1. And that is the same answer that we got earlier on. So as you can see, that instead of going through the process of expanding brackets, we can follow these rules to quickly simplify expressions. Let's look at another example. Here we have m minus 7n and all of this to the power 2. This is an example of the square of a difference rule. We can rewrite this as m minus 7n times m minus 7n. And when expanded, we will get m squared minus 7mn minus 7mn plus 49n squared, which simplifies to m squared minus 14mn plus 49n squared. Now let's see if we get the same answer if we apply the square of a difference rule. Again, a represents m, b represents 7n. Therefore, a squared equals to m squared, 2ab equals to 14mn, and b squared equals to 49m squared. When we combine all of this, it will give us m squared minus 14mn plus 49n squared, which is the same answer as what we got earlier on here. This last example is to show the difference of a square rule. You can identify a difference of a square when the variables and the coefficient are the same, but the signs within the brackets are different, and that's the case in this example. When we expand this, we will get x squared minus 6xy plus 6xy minus 36y squared, which simplifies to x squared minus 36y squared, as we can cancel out the 6y's. The a represents x, b represents 6y, therefore a squared equals to x squared, and b squared equals to 36y squared, which gives us x squared minus 36y squared, which is again the same answer as previous. As you can see, I've put up 2 questions on the screen right now. I'd like you to pause the video and have a go at these questions on your own. Hopefully you've had a chance to attempt the questions. Let's go through the solutions now. Question number 1. So the first step is to expand the brackets, which will give us m squared plus 2mq plus q squared minus bracket m squared minus 2mq plus q squared. Please keep in mind that we've used the square of a difference and square of a sum rule to expand these brackets. Now we need to expand this second bracket by multiplying all of these individual terms with the minus outside of the bracket. And this will give us m squared plus 2mq plus q squared minus m squared plus 2mq minus q squared. Let's now collect all the like terms. So we can cancel out the m squared and the q squared, which leaves us with 4mq. Let's have a go at question number 2. So again, the first step will be to expand the brackets. This gives us bracket xy plus x over y plus y over x plus 1 over xy, bracket closed, plus xy minus x over y minus y over x plus 1 over xy. The second step is to collect the like terms. So we can cancel out these fractions here, which leaves us with 2xy plus 2 over xy. This is the end of the video on expansion of brackets. If you have any questions or comments, then please leave them in the comments section below. Thank you for watching.